The National Electrical Code, or NEC, does not specifically address the issue of open high-voltage connections for spark ignition circuits in ovens. However, the following general requirements apply. Firstly, Section 110.12, which states that electrical systems and equipment shall be installed and maintained in accordance with this code. Secondly, Section 210.5, stating that all wiring methods shall be installed in a neat and workmanlike manner. Thirdly, Section 90.1, stating all electrical equipment shall be installed and used in a manner that minimizes the possibility of fire or physical harm to persons. NFPA 61, which is the standard for the prevention of fires and dust explosions in agricultural and food processing facilities, although not a part of the NEC, is often referenced in conjunction with electrical installations in food processing facilities. Section 9.41 from the 2017 edition states that wiring shall be installed in rigid conduit, intermediate metal conduit, electrical metallic tubing, or other approved raceways. NEC Advisory Circular 19 provides guidance on the installation of electrical equipment in commercial cooking areas. Section 5.21.1 states that all circuits that are energized from the master control switch shall be enclosed in approved raceways or enclosed in a gas-tight container acceptable to the authority having jurisdiction. Based on the above requirements, it is generally not recommended to leave high-voltage connections for spark ignition circuits open and exposed. The NEC requires wiring to be installed in raceways to protect it from physical damage and prevent electrical shock. The best practice is to enclose the high-voltage connections in an approved raceway or container that provides protection from accidental contact and environmental hazards. This will ensure compliance with the applicable codes and standards and reduce the risk of electrical hazards. Now let's delve deeper into each of these points to provide a comprehensive understanding of the requirements and best practices. Starting with the National Electrical Code. While it doesn't have a specific section dedicated solely to spark ignition circuits, its general principles are crucial. Section 110.12 emphasizes the importance of installing and maintaining electrical systems and equipment in accordance with the code. This means that all aspects of the installation, from the selection of materials to the execution of the wiring, must adhere to the standards set forth in the NEC. This overarching requirement sets the tone for a safe and compliant installation. Section 110.12 essentially means you have to follow the rest of the code book. Section 210.5 builds upon this foundation by mandating that all wiring methods be installed in a neat and workmanlike manner. This seemingly simple requirement has profound implications for the safety and reliability of the electrical system. A neat and workmanlike installation minimizes the risk of accidental damage, reduces the likelihood of loose connections, and makes it easier to troubleshoot and maintain the system in the future. This section ensures that the installation is not only electrically sound, but also visually organized and professionally executed. Section 90.1 reinforces the primary objective of the NEC, which is to minimize the possibility of fire or physical harm to persons. This section underscores the importance of using electrical equipment in a manner that prioritizes safety. It serves as a constant reminder that all electrical installations must be designed and executed with the utmost care and attention to detail. Section 90.1 reminds us what the purpose of the NEC is. Moving on to NFPA 61, this standard provides specific guidance for electrical installations in agricultural and food processing facilities. Section 9.41 of the 2017 edition explicitly states that wiring shall be installed in rigid conduit, intermediate metal conduit, electrical metallic tubing, or other approved raceways. This requirement is intended to provide a high level of protection against physical damage, moisture, and other environmental hazards that are commonly encountered in these types of facilities. Conduit and raceways provide a physical barrier that protects the wiring from impact, abrasion, and other forms of damage. They also help to contain any potential electrical faults, reducing the risk of fire or electric shock. This section of the NFPA 61 is very important, since the oven will most likely be located at a food processing facility. NEC Advisory Circular 19 provides further guidance on the installation of electrical equipment in commercial cooking areas. Section 5.2.1.1 specifically addresses circuits that are energized from the master control switch, requiring them to be enclosed in approved raceways or gas-tight containers. This requirement is intended to prevent accidental contact with energized components and to protect the wiring from the harsh conditions that are often found in commercial kitchens, such as high temperatures, moisture, and grease. This advisory circular reinforces the importance of providing a robust and reliable enclosure for electrical wiring in commercial cooking environments. This section ensures that any high-temperature environment can be accounted for to prevent the wiring from any type of overheating. Based on these requirements, the general consensus is that leaving high-voltage connections for spark ignition circuits open and exposed is not recommended. The NEC emphasis on raceways for wiring protection is a clear indication that exposed wiring is generally discouraged. Raceways provide a physical barrier that protects the wiring from damage, reduces the risk of electrical shock, and helps to contain any potential electrical faults. Exposing high-voltage connections creates an unnecessary risk of accidental contact, which can have serious consequences. Furthermore, exposed wiring is more vulnerable to environmental factors such as moisture, dust, and rodents, which can compromise its integrity and increase the risk of failure. The best practice, therefore, is to enclose the high-voltage connections in an approved raceway or container. This provides a comprehensive level of protection against accidental contact, physical damage, and environmental hazards. Approved raceways and containers are designed to meet specific safety standards and are rigorously tested to ensure their ability to withstand the stresses and strains of the environment in which they are installed. By using these types of enclosures, you can ensure that the electrical system is safe, reliable, and compliant with the applicable codes and standards. In summary, while the NEC may not explicitly address open high-voltage connections for spark ignition circuits, its general requirements, along with the recommendations of NFPA 61 and NEC Advisory Circular 19, strongly suggest that such installations are not recommended. The emphasis on raceways, enclosures, and protection against physical damage and environmental hazards is a clear indication that high-voltage connections should be properly enclosed to ensure safety and compliance. By following these best practices, you can significantly reduce the risk of electrical hazards and create a safer working environment. Now let's explore specific types of raceways and enclosures that are suitable for high-voltage spark ignition circuits. Rigid metal conduit, or RMC, is a heavy-duty raceway that provides excellent protection against physical damage and environmental hazards. It is typically made of steel or aluminum and is available in various sizes and thicknesses. RMC is suitable for both indoor and outdoor applications and can be used in corrosive environments with the appropriate coatings. Intermediate metal conduit, or IMC, is a lighter weight alternative to RMC that still provides good protection against physical damage. It is also made of steel or aluminum and is available in various sizes. IMC is typically less expensive than RMC and is easier to install, making it a popular choice for many applications. Electrical metallic tubing, or IMT, is a thin-walled raceway that is typically made of steel or aluminum. It is commonly used for indoor applications where physical damage is not a major concern. EMT is lightweight and easy to bend, making it a cost-effective option for many wiring installations. Flexible metal conduit, or FMC, is a flexible raceway that is typically made of steel or aluminum. It is used in applications where flexibility is required, such as connecting to motors or other equipment that may vibrate or move. FMC provides good protection against physical damage and is available in various sizes. Liquid-tight flexible metal conduit, or LFMC, is a flexible raceway that is similar to FMC but has a liquid-tight jacket that provides protection against moisture and other liquids. It is used in applications where the wiring may be exposed to wet or damp conditions. Non-metallic conduit, or PVC conduit, is a rigid raceway that is made of polyvinyl chloride. It is used in corrosive environments where metal conduits may rust or corrode. PVC conduit is lightweight and easy to install, making it a popular choice for many applications. In addition to raceways, enclosures are also used to protect high-voltage connections. Enclosures are typically made of metal or plastic and are available in various sizes and shapes. They are used to house electrical components such as terminals, connectors, and splices. Enclosures provide protection against accidental contact, physical damage, and environmental hazards. When selecting a raceway or enclosure for a high-voltage spark ignition circuit, it is important to consider the following factors. Firstly, the voltage rating of the circuit. Make sure that the raceway or enclosure is rated for the voltage of the circuit. Secondly, the environmental conditions. Consider the environmental conditions in which the raceway or enclosure will be installed, such as temperature, moisture, and corrosive substances. Thirdly, the physical protection requirements. Determine the level of physical protection that is required to protect the wiring from damage. Fourthly, the applicable codes and standards. Ensure that the raceway or enclosure complies with all applicable codes and standards, such as the NEC and NFPA 61. Now let's consider some specific installation tips for high-voltage spark ignition circuits. Firstly, always disconnect the power before working on any electrical circuit. This is essential to prevent electric shock. Secondly, use properly insulated tools and equipment. This will help to protect you from electric shock. Thirdly, follow the manufacturer's instructions for installing the raceway or enclosure. This will ensure that the installation is safe and reliable. Fourthly, make sure that all connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to fire. Fifthly, test the circuit after installation to ensure that it is working properly. This will help to identify any potential problems before they cause a hazard. In addition to these installation tips, it is also important to follow some general safety precautions when working with high-voltage circuits. Firstly, never work alone. Always have someone nearby who can assist you in case of an emergency. Secondly, wear appropriate personal protective equipment such as safety glasses and gloves. Thirdly, be aware of your surroundings and avoid contact with any grounded surfaces. Fourthly, if you are not qualified to work on high-voltage circuits, hire a qualified electrician. Working with high-voltage circuits can be dangerous, so it is important to take all necessary precautions to protect yourself and others. By following these guidelines, you can ensure that your high-voltage spark ignition circuit is installed safely and reliably. Let's summarize the key points. High-voltage connections for spark ignition circuits should not be left open and exposed. The NEC requires wiring to be installed in raceways to protect it from physical damage and prevent electrical shock. NFPA 61 recommends the use of rigid conduit, intermediate metal conduit, electrical metallic tubing, or other approved raceways and food processing facilities. NEC Advisory Circular 19 recommends that circuits energized from the master control switch be enclosed in approved raceways or gas-tight containers. The best practice is to enclose the high-voltage connections in an approved raceway or container that provides protection from accidental contact and environmental hazards. When selecting a raceway or enclosure, consider the voltage rating, environmental conditions, physical protection requirements, and applicable codes and standards. Follow proper installation techniques and safety precautions when working with high-voltage circuits. By following these recommendations, you can ensure that your high-voltage spark ignition circuit is installed safely and reliably. One more aspect to consider is grounding. Proper grounding is essential for the safe operation of any electrical system, and high-voltage spark ignition circuits are no exception. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing a dangerous build-up of voltage. The NEC requires that all metal raceways and enclosures be properly grounded. This can be accomplished by connecting the raceway or enclosure to a grounding electrode, such as a ground rod or a metal water pipe. The grounding conductor must be sized according to the NEC and must be properly connected to the grounding electrode. In addition to grounding the raceways and enclosures, it is also important to ground the equipment that is connected to the high-voltage spark ignition circuit. This includes the spark igniter itself, as well as any associated control panels or other devices. The equipment, grounding conductor, must be sized according to the NEC and must be properly connected to the equipment. Proper grounding is essential for preventing electric shock and fire. It is important to ensure that all grounding connections are tight and secure and that the grounding system is properly maintained. Another consideration is overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices are essential for preventing fires and protecting equipment from damage. The NEC requires that all electrical circuits be protected by overcurrent protection devices. The size of the overcurrent protection device must be matched to the ampacity of the circuit conductors. The ampacity of a conductor is the maximum amount of current that it can safely carry. The NEC provides tables that list the ampacities of various types of conductors. It is important to select an overcurrent protection device that is appropriate for the circuit being protected. An overcurrent protection device that is too small will trip unnecessarily, while an overcurrent protection device that is too large will not provide adequate protection. In addition to overcurrent protection, it is also important to consider surge protection. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges, such as those caused by lightning strikes or power line disturbances. Voltage surges can damage or destroy sensitive electronic equipment. SPD are typically installed at the service entrance of a building to protect the entire electrical system. They can also be installed at individual pieces of equipment to provide more localized protection. The NEC recommends the use of SPD in areas that are prone to lightning strikes or power line disturbances. When selecting an SPD, it is important to consider the voltage rating, surge current capacity, and protection level. Now let's consider some common problems that can occur with high voltage spark ignition circuits. One common problem is a faulty spark igniter. The spark igniter is responsible for creating the spark that ignites the fuel. If the spark igniter is faulty, it may not produce a spark, or the spark may be too weak to ignite the fuel. Another common problem is a loose connection. Loose connections can cause overheating and arcing, which can lead to fire. It is important to ensure that all connections are tight and secure. Another problem can be damaged wiring. Damaged wiring can cause short circuits or ground faults, which can be dangerous. It is important to inspect the wiring regularly and replace any damaged sections. Another issue is moisture intrusion. Moisture can cause corrosion and short circuits, which can damage the electrical system. It is important to protect the wiring from moisture by using appropriate raceways and enclosures. When troubleshooting a high-voltage spark ignition circuit, it is important to follow proper safety precautions. Always disconnect the power before working on any electrical circuit. Use properly insulated tools and equipment. Wear appropriate personal protective equipment. If you are not qualified to troubleshoot high-voltage circuits, hire a qualified electrician. Regular maintenance is essential for ensuring the safe and reliable operation of high-voltage spark ignition circuits. Regular maintenance should include the following steps. Firstly, inspect the wiring for damage. Secondly, check all connections for tightness. Thirdly, test the spark igniter. Fourthly, clean the raceways and enclosures. Fifthly, verify the grounding system. Sixthly, test the overcurrent protection devices. Seventhly, inspect the surge protection devices. By performing regular maintenance, you can identify and correct potential problems before they cause a hazard. Finally, always consult the manufacturer's instructions for specific maintenance recommendations. Remember, safety should always be the top priority when working with electrical systems. If you are unsure about any aspect of the installation, maintenance, or troubleshooting of a high-voltage spark ignition circuit, consult a qualified electrician. By following these guidelines, you can ensure that your high-voltage spark ignition circuit is installed safely, reliably, and in compliance with all applicable codes and standards. Also be sure to check with the authority having jurisdiction, or OJ, for any local code requirements that may go above and beyond the NEC, NFPA or other advisory circulars. The AHJ has the final say.